Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Nur Syafiqah binti Bezul Ahmad. I am postgrad student from Faculty of Electrical Engineering, University Teknologi Mara, Shah Alam. My presentation was focused on design of an Internet of Things based smart irrigation and fertilization system using fuzzy logic for chili plant. Let's start with introduction. The chili plant is one of the popular plants with high demand, especially in market wholesale and food industries. So the quality of chili need to be monitored to fulfill the needs of industry. The process of chili plants start with seeds to sprouts, and then germinates and weights before transfer into poly bag. And the last phase is the chili plants will start grow up. The sufficient amount of nutrient, which is fertilizer and water, are crucial for the plant to grow well. The plant was started to produce its fruits with color of green and then turn into red when ripe. The important parameters that need to be monitored during this phase is the soil pH and the moisture of the soil. For a healthy growth, the plant requires a controlled environment with good irrigation and fertilization system. In this study, fuzzy logic is used to control the amount of nutrient and being monitored by smart irrigation and fertilization using IOT. So, the plants will grow up with enough nutrients and grow healthier. Okay, next for problem statement. The current technique that most farmers use to improve the growth of their crops is fertigation system. Normally, the system use a tank of fertilizer solution and a water pump to distribute the solution. A timer is set to ensure that the water pump flows on time 6 times a day. Unfortunately, there is no monitoring on soil conditions where the soil moisture and pH level were unknown. The plants might have excessive moisture, cause the fertilizer did not dissolve in the soil. Okay, in this study, there are two objectives. First, design a controller using fuzzy logic system to control the amount of fertilizer needs by plants. And the second, build a smart system for irrigation and fertilization system using Internet of Things IoT to monitor condition and control the value of pH soil and moisture of the soil. Okay, next for methodology. For hardware implementation, Figure 2 shows the block diagram of project. The input, there are 3 input. First, pH sensor. Second, soil moisture sensor. And third, flow rate sensor. For the system, it consists of microcontroller using Arduino and instruct by the fuzzy logic. Next, a Wi-Fi module was used to interface the system with the mobile phones. And next, for the output, it consists of valve, water pump and data logging. Okay, next for fuzzy logic system, it consists of fuzzy rules and membership function. In this study, there are 3 fuzzy rules. Table 1 shows the fuzzy rule for alkali. Table 2 shows the fuzzy rules for neutral, and table 3 shows the fuzzy rule for acid. For membership function, it consists of 2 input and 3 output. Figure 3 and Figure 4 shows the membership function for pH soil and soil moisture. Figure 5, 6 and 7 shows the membership function for acid solution, neutral solution and alkali solution. Okay, for the data display, the Blink application is used to interface the user with the project. The mobile phone was connected via Wi-Fi using Node MCU to get the latest update on the condition of the soil for the plant. The user able to turn on and off water pump using button in mobile apps. Okay, Figure 8 shows the condition of the moisture and the pH value for the soil displayed on the mobile phone. The graph will indicate the reading of pH value and moisture versus time. Okay, next for fuzzy logic validation test. Figure 9 shows the block diagram of simulation in Simulink from MATLAB. The simulation result was tabulated in table 4, and next for validation test for acid solution, neutral solution and alkali solution was tabulated in table 5, 6 and 7. Based on the table 5, 6 and 7, the comparison have been made between simulation output and experiment output. It shows that the simulation output has small difference to the experiment output. It proved that the simulation was accurate to real application. Okay, let's look at plant growth. Figure 10 shows plant A and plant B. For plant A, it was not controlled by the system, and for plant B was controlled by the system. The water solution with 7 pH value for plant A and the fertilizer solution with 5.5 pH value for plant B. The amount of watering plants are same for both plants, which are 220 ml every day. The solution will pour twice a day around 7 a.m. in the morning and in the evening around 6 p.m. Both plants were placed at the same place where the plants can get enough sunlight. The type of soil for both plants are also same. Every week the data will be collected from the plants to make a comparison between both plants. So the data was tabulated in table 8. It shows the result from plant growth for 8 weeks. Okay, in conclusion, this study was successfully achieved the objective of the project. From the result, it shows that the plant B with fertilization solution based on fuzzy logic system has more prominent compared to the plant A in terms of growth, where the plant have absorbed sufficient amount of nutrient compared to the traditional ways. Besides that, the condition of pH soil and soil moisture was fully monitored by smart irrigation and fertilization using IOT. And lastly, the project was successfully developed better irrigation and fertilization system for chili plant. Okay. Last but not least, the author would like to express gratitude to a final year project student from Faculty of Electrical Engineering, Muhammad Hazim Shakirin, who had successfully finished this project. This project was supported by Faculty of Electrical Engineering, UiTM Shah Alam. The authors would also like to express our gratitude to Research Management and Innovation, IRMI, UiTM, for financial support through Research Entity Initiative Grant, IRMI. Okay, last, this is a reference. Okay, if have any question, you can email me at myzidah@uitm.edu.my, and thank you for your time.